Hello everyone and welcome to the next lecture. Today we will solve some more examples on subspace of V. So here the next example is show that W is equal to F such that, what is the condition? F of x square is equal to F of x bracket square. See the condition carefully. F of x square is equal to F of x bracket square is not a subspace of V. Means we have to show that it is not a subspace of V. It does not satisfy the condition. What is the condition? Our alpha f plus beta g does not belongs to W, or you may take alpha u plus beta v. Okay, now f and g belongs to W, means f and g both satisfied sub condition. What is that condition? F of x square is equal to f of x bracket square, and g of x square is equal to, we can write g of x bracket square. Correct? For alpha beta belongs to R. Now consider this alpha f plus beta g operating on x square. We have to show that it is alpha f plus beta g bracket square of x bracket square. Okay. Multiply x square inside. What I get? Alpha f of x square plus beta g of x square. But what is value of f of x square? Value of f of x square is f of x bracket square, and value of g of x square is g of x bracket square. So alpha f of x bracket square plus beta g of x bracket square. But I want alpha f plus beta g. Yes, what I want? Alpha f plus beta g of x and total bracket square, and that is not possible here. So it is not equal to alpha f plus beta g of x bracket square. Therefore alpha f plus beta v does not belongs to W. Therefore W is not a subspace. Let us try for one more example here. Suppose I have here V is equal to the vector space defined on some interval AB, or you may say that set on continuous functions, and we can define W is equal to f such that f belongs to set of continuous functions, means our function f is integrable, and here integral a to b f of x dx is equal to 1. Integral a to b f of x dx equal to 1, means W contain only those functions whose integration is 1. Correct? Between a to b. Okay, if I take two functions f and g, then f and g belongs to W. It indicates that integration of f and integration of g is 1. Both have integration 1. Correct? Now check for alpha f plus beta g. This also must have integration 1. Then we can say that it belongs to W. Correct? So let us try. Take the integration a to b alpha f plus beta g of x. Multiply x inside and separate the integral from this addition sign. या addition sign पासून वेगवेगळ्या. So here alpha outside, or you may write initially a to b alpha f of x dx plus integral a to b beta g of x dx. Correct? Alpha constant, beta constant you can take outside. What is value of a to b f of x dx? Alpha into a to b f of x dx plus beta a to b g of x dx. Will you tell me the value of a to b f of x dx and g of x a to b g of x dx? It is 1, 1. Yes, these values are 1. Therefore alpha into 1 plus beta into 1. Correct? So I get alpha plus beta, but I must have 1. Alpha plus beta is not equal to 1. Therefore W is not subspace. W is not a subspace. Understood? Okay. Take one theorem. If you want to use it, you can use, or you can solve by our usual method alpha u plus beta u. In both way I will explain you. So here one theorem is there. A non-empty subset W of a vector space V a non-empty subset W of a vector space V is a subspace if W is closed under linear combination. Means what? If I have vectors V1 and V2, then C1 V1 plus C2 V2 belongs to W, or you may take in general C1 V1 plus C2 V2 plus dot 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 Cn Vn belongs to W if I have n vectors. So in fact we are not going to use this theorem. If you want to use, you can use it. Suppose I have W. Example, show that W is a subspace. So what is W here? Matrix xyz. So here vector xyz such that x minus 2y plus z is equal to 0, right? If I write it in linear combination of vectors, then we can say that W is a subspace. Or our usual method we can use. First I will tell you here which method is there. Okay. XYZ. How I write XYZ? From our given condition, what is value of x? From given condition, what is value of x? Value of x is, yes, transfer y and z to RHS. Y and z RHS la patva. So here I get 2y minus z. Correct. So I just put here 2y minus z, y and z. Now separate the terms of y and z. See here, 2y minus z I can write 2y, y and 0 in one matrix plus minus z, 0 and z in another matrix. Means in one matrix I write only terms of y, and in second matrix I write only terms of z. Now take y common. So I get 2, 1, 0. And here take z common. I get minus 1, 0, 1. Correct? Therefore W is a linear combination of vectors. So we can say that W is a subspace. Or if you don't understand in this way, then directly start. Take two elements, x1, y1, z1, u, and v is x2, y2, z2. Correct? And belongs to W means what? It must satisfy the condition. What is our condition? x1 minus 2y1 plus z1 is equal to 0. Second condition, x2 minus 2y2 plus z2 is equal to 0. So these two conditions must be satisfied by these two elements because they belongs to W. Now consider alpha u plus beta v. Alpha u plus beta v. Correct? So what I get? Alpha u plus beta v. Alpha u plus beta v is equal to, yes, alpha into x1 y1 z1 plus beta into x2 y2 z2 is equal to what I get? Yes, if I do this calculation, alpha x1 plus beta x2, alpha y1 plus beta y2, alpha z1 plus beta z2. Now you have to check that this element belongs to W or not. For that what we required? We required x minus 2y plus z equal to 0. So x means first value minus 2 into second value and plus z into third value. So take that. Alpha x1 plus beta y1, correct, minus 2 into second value alpha x2 plus beta y2, correct, and third value plus alpha x3 plus beta y3 is equal to, just separate it out, and from the first bracket take alpha common, from the second bracket take beta common. So here alpha in bracket, what I get? Tell me. x1 minus 2x2 plus x3 plus beta in bracket y1 minus 2y2 plus y3. Correct? But what is value of x1 minus 2x2 plus x3? In our first step we have written it is 0. So alpha into 0 plus beta into 0 means it is equal to 0. So this condition is satisfied. Therefore we can say that alpha u plus beta v belongs to W. So I told you the second method also. So according to you, you just decide what you have to do and which examples we have to solve. One more example I will show you in this way. Show that W is equal to A0 BC and A plus B plus C equal to 0 is a subspace. That means you have to take two elements. Instead of any other method, just take two elements, alpha u plus beta v, because that method is easier and we can easily understood it. Right? U is one matrix, B is another matrix. Take that. U is equal to, take the matrix A1 0, B1 C1. And second matrix, V is equal to, you may take A2 0, B2 C2. Correct? A2 0, B2 C2, and take alpha u plus beta v and check the condition that A plus B plus C equal to 0, because A1 plus B1 plus C1 equal to 0, A2 plus B2 plus C2 equal to 0. You will easily get the answer. Therefore, we can say that our vector space, our subset, is a subspace of V. You can try for many examples. Here I will show you one example. Show that W is not a subspace of V. W is a set of matrix such that determinant is equal to 0. Means W is defined in this way. W is equal to matrix A, B, C, D. Correct? Such that determinant of A is 0. Or you may say that instead of A, B, C, D, only matrix A, such that matrix determinant of A is equal to 0. But this is not true. This is not a subspace, because there are some matrices whose addition, if I take, its determinant is not equal to 0. If I take a matrix A, then 1 0 0 1, determinant of A is 0. Correct? Then matrix B, its determinant is equal to 0, 0 0 0 1. But if I take A plus B, I get 1 0 0 1. It is identity matrix, its determinant is 1. So it is determinant not equal to 0. Therefore, W is not a subspace. Now some exercises are there. You just try by your own and try to find the answer. If you have a difficulty, then you can ask me. Understood? Some of the examples I may help you to solve directly in few videos, right? But I have to take some more concept. So we stop here and we will see the next examples or next concept in the next video.